So, as we know, the second atomic model is called as Rutherford's alpha particle scattering experiment. There is what discovery of nucleus. So, for this experiment, and has been proved successfully the concept of nucleus, which was his greatest contribution to the physics actually. So that is why he awarded for the discovery of nucleus, he awarded the Nobel Prize in 1908. So that is the world's one of the most priceless award, we can say that. And same way, and one more speciality of his death also. So because of his greatest contribution to the physics of this concept of nucleus, so he has been buried near to the tomb of world's greatest scientist. Who is that? Mr. Sir Isaac. Sir Isaac whom, guys?
Newton, sir.
Newton. So because of his greatest contribution, because of the discovery of the nucleus, so it helped so many aspects in the physics. That is the reason he has been even in death, he has been recognized with the like buried near to the tomb of Mr. Sir Isaac Newton. So this is what about Ernest Rutherford, who is one of the greatest scientists who has been proved experimentally for the first time, who studied the internal properties of atoms. So now let us discuss what is this alpha rays scattering experiment and what is his observations and all. Okay. Now first experiment, because in our book, your book, no experiment is given. Only the diagram given in our book is the observation diagram. So that is why let us study about what is this experiment and how it has been done. That everything we will study now. All of you observe, this experiment is not there in our book. If you want, you can draw this diagram later. I'll send it in the group also. So now, this is what the experimental setup done by Mr. Ernest Rutherford to study the properties of atom. Okay, or to study the structure of an atom. Now, observe very carefully here. For this, to know the internal structure of an atom, so all of you can keep a name, alpha rays scattering experiment. Alpha rays scattering experiment. Okay, so anyone having doubt, please kindly ask me. And this is the most important one because exam, this is surely they will ask, even higher classes also. So this is what the experimental setup he has been made. Now, to know the internal structure of an atom or the arrangement of subatomic particles. What is the subatomic particles known to them by the time? Yes, please. What is subatomic particles? Electrons and
Protons.
yes or no? So, to know this internal structure of an atom or the arrangement of these subatomic particles in an atom, Mr. Rutherford, he bombarded a thin gold foil with the alpha particle. What do you mean by bombarded, Mr. Omar? Bombarded. What do you mean by bombarded? Means collision, guys.
Sir,
Yes.
bomba taila.
Bombarded. Bombarded. Bombarded means, for example, I'll say I will bombard you, means I will kick you. That is the meaning of bombarded. Understand, Mr. Omar? Hitting.
Okay, sir.
Hitting, we can say. Collision or hitting. So, to study this experiment, so there is no verification, there is no proof for how he has got this idea, but he has been done. So, what he has been done means he bombarded these alpha particles. I will say you what do you mean by alpha particles. Okay, so please remember that is also very important because class 10th also it will come. So Rutherford bombarded a thin gold foil. Bombarded a thin gold foil. That is why this is called as gold foil experiment. Also, we can say gold foil experiment, thin gold foil with alpha particles. Okay, so I will say you what is this alpha particles, and the resultant particles were allowed to strike on zinc sulfide coated screen. That is what the blue color one which you are noticing. That is what is the quote here, everybody? What is this quote? Harish, zinc sulfide coated. So he made to collide these alpha particles with this thin gold foil, and after that the particles, the resultant particles, after the hitting, after colliding with this gold foil, whatever the particles are coming out from it, he made to hit this zinc sulfide coated screen. That is what the blue color screen which you are seeing here surrounding like a compound wall. Understand, Mitakshri? Now,
Yes,
what
sir.
what do you mean by alpha particles? So please remember that alpha particles means just only a positively charged atoms. Okay, so if you remove electrons from it and only it contains a positive charge. For example, if you take helium, how many electrons and how many protons? Anybody? Yes, please. Helium atom. Harish, helium atom, 2 electrons, and as well as it is having 2 protons. So if I remove these 2 electrons, then they will turns into helium 2 plus, He 2 plus. Is it right or wrong? Please respond, all of you. So helium, you remember that we have been done at the beginning of the chapter. What is happening? Properties of how this cathode rays and anode rays are forming. There we have been done. Helium, if I pass electric current at the low pressure, what will happen, guys? It will turns into whom? Electric current at low pressure. Tell me, check your notebooks and tell me. It will turns into what? He plus 1e minus. Is it yes or no? All of you? Yes, please. Nobody is answering. You have written or
Yes, sir.
verified. Now, same way, if I remove 2 electrons, all of you observe, if I remove 2 electrons from it, then it will turn into He2 plus. So this He2 plus only we is to called as what particles, guys? All of you. Who is to called as alpha particles. Understand, Amma? Abhirami?
Yes, sir.
Yeah. So a positively He2 plus, that is what we is to called as alpha particles. So remember that the alpha particles are positively charged helium nuclei emitted from a radioactive source. This is what the radioactive source. From this, I am emitting the alpha particles. This alpha particles only called as positively charged helium nuclei. Remember that. Positively charged helium nuclei. That is what He2 plus. That is called as alpha particle. Exam also they'll ask you, what is alpha particle? You have to write what, guys? Alpha particles are positively charged helium nuclei. Bracket you should write He2 plus. That is what do you mean by alpha particle? And they're emitting from where, guys? They're emitting from where? Radioactive source. Radioactive source. This is what the source of helium He2 plus particle. Now, remember all of you, this He2 plus, basically He2 plus will carries the mass of, what is the atomic mass of He2 plus, 4U. What do you mean by 4U, guys? Anybody can tell me? What is the 4U? U means what? Third chapter we studied.
Unified mass, sir.
unified mass or atomic mass unit. So what is the helium alpha particles atomic mass? All of you? What is the atomic mass? 4U. And what is the charge? Charge is what? Mitakshri? Charge of how much? +2 units. Okay. Charge of +2 units. And the mass is 4 units and charge of +2 units. So now this is what he has been taken. And have you noticed here one yellow color one? What is the name of this one they mentioned? A thick, a thin foil. What is this thin foil called as? All of you. Here you can see a thin foil. What is this?
Gold, sir.
Gold foil. And almost the thickness of the thin foil. About how many atoms? Almost is it
1000.
atoms? 1,000 atoms. Why means you might be studied in physics, physical properties of gold. Gold is the highest malleable in nature. Ductility and malleability. Class 8 you might be studied. Malleability and ductility. Do you remember everybody? Yes, please.
Yes, sir.
Yeah, without breaking. So that is why he has chosen the gold, because gold we can make a lightest thickness as it is having high malleability and ductility. That is the reason Mr. Rutherford has been taken a gold foil, extremely minute thickness, almost the thickness of that, which is equals to how many atoms, guys? How many atoms? 1,000 atoms. So this is what the experimental setup has been taken by Mr. What is his name? Rutherford to study this, to study the properties of atom or internal properties of atom. Anyone having in this doubt, please ask me. Are you clear, everybody? All of you? Yes, please.
Yes, sir.
Yeah. Now, if you observe very carefully, when he has been conducted, so the gold foil with a thickness of 1,000 atoms was bombarded by alpha particle. So he is releasing the alpha particles from the radioactive source, and these alpha particles are going and striking the gold foil, and from that the resultant alpha particles are hitting the coating. What is that layer called as? The compound. What is that layer? Zinc sulfide coated screen. So that is how it will be happening. So once they bombarded these alpha particles, which were first passed through the fines, this is a small slit you can see here. From the small hole, he has been trying to pass all the alpha particles very fastly, and they are going to hit this gold foil. So once this gold foil, this alpha particles are hitting or bombarded, then what is the results he has observed? That is what the first thing. So once these alpha particles are coming from this, hitting this gold foil, and the resultant alpha particles, he has been observed a bright flashlight. Bright flash on where? On the screen here. Here he observed a bright flash on a circular screen coated with a zinc sulfide due to the scattering of alpha particles. So the alpha particles which are coming from the gold foil, the resultant alpha particles, we can say, they are scattering the light. What do you mean by scattering? Splitting the light into all the directions. That is what the meaning of scattering. If you don't know, you can write that word. So scattering, what do you mean by scattering? Means splitting the light into all the directions. That is the meaning of scattering. Splitting up of light randomly is called scattering of light. So even chemistry second chapter, colloids will scatter the light. Have you noticed it? We studied that, all of you. Yes, please. Yes, please respond. Colloidal substances will scatter the light, will make the path of the light visible to us. Do you remember or not? I want response.
Yes, sir.
Yes, sir.
That is what it is, the same thing. Scattering means making the path of the light visible to us. That is what scattering. That is why you can see early morning sunlight is coming from a small hole of a window. The dust particles, everything you can able to see. Can you able to see it or not? Everybody. That is only called as scattering. Making the path of a light visible to us is called as scattering. So once these alpha particles hitting this gold foil, and whatever the resultant, whatever the after hitting, whatever the particles are coming out, these particles, they're scattering the zinc sulfide coated screen. Light is scattered. So that is why he observed a bright flash on this screen, which is coated with the zinc sulfide. So he assumed that alpha particles to be much heavier than the protons, and he expected that alpha particles would be deflected by subatomic particles present in the atom of gold foil. Do you understand, all of you? So, as we know, what is the mass of the alpha particles? All of you. What is alpha particles mass? Here. How much amount? Alpha particles 4U. Understanding? And what is the charge? Charge is what? 2 units. So what Mr. Rutherford thought that this alpha particles after hitting this gold foil, he thought that all the particles will come back. Do you understanding? That is his prediction. But here, experiment completely oppositely takes place according to his expectations. So he expected that all the particles, due to its heavy mass, compared to the protons, alpha particles mass is more. So he thought that all the particles will come back. But surprisingly, he noticed that there is no kind of large deflections. So the result of experiment were beyond his expectations. He expected something during the experiment, some other thing is happened. So he noticed that when the particles struck this thin metal gold foil, okay, some of them scattered instead of continuing straight through it. That is what you can notice it. They are deflecting in a different directions, and very few only is scattered, and only 1%, very less percentage of particles are reversing back exactly. But you can see some of them scattered instead of continuing in a straight line. So they have been diverted with some angles, and as well as the discovery of nucleus is not done by Mr. Rutherford. Do you understand, everybody? So actually, discovery of nucleus, we studied that Rutherford is discovered, but it is not discovered by Rutherford. He thought that alpha particles will come back after hitting the gold foil because alpha particles heavier mass than proton mass. So during the experiment, all his results were wrong. It is like beyond expectations. And also he noticed that most of the particles are scattered from the gold foil. Very few only they are reversed. Understanding? And with these observations, his assistant, you people won't believe that. We people, how you people will treat assistant, you imagine that. But Mr. Rutherford imagined. His assistant in his lab discovered this nucleus. Not done by Mr. Rutherford. The discovery of nucleus occurred when Hans Geiser, one of the assistants of Rutherford, noticed that most number of alpha particles scattered by an angle greater than 10 degrees. That is what much more than what he predicted. That is what you can see. Most of the alpha particles, they have been scattered 10 degrees more 10 degrees was much more than what they predicted. So that is what the helping them to discover the nucleus. So they thought that after hitting this nucleus, this is what middle, all the alpha particles are deflecting by hitting this center part. That is what a positive charge, because they have also taken a positive charge only, and here also positive charge. So positive charge shows repulsion or attraction. Yes, please. It will shows repulsion. That is what, after hitting that, they have been diverted with almost angle greater than 10 degrees. So that is only leads to discovery of nucleus inside the atom. And they said that a nucleus or positive charge is located very deeper inside the atom, and most of the particles are scattered by this. That is why he said, so most of the space inside the atom is empty, nothing is there, and very few is reversing back and as well as deflecting greater than almost 90 degrees. So that is what it is. Here they have been said electrons are revolving around the nucleus. So these are all observations of Rutherford's atomic model. So this is what experiment they have been conducted. He conducted this experiment for some purpose, and observations goes entirely beyond his experiment, beyond his expectations. So what is his observation, and what is this atomic model? What is the conclusions made by him? And same way, why again, what is the drawbacks of this Rutherford atomic model? These all the things we'll discuss in our tomorrow's class. Tomorrow we'll try to finish even Bohr's atomic model also. So this is what is alpha particle scattering experiment. So just I explained you how he has been done the experiment, and tomorrow's class will study what is his observations, and same way what is the conclusions derived by Rutherford, and what is the model Rutherford atomic model, and what is the limitations of Rutherford atomic model. So everybody think that nucleus has been discovered by Rutherford, but it has been occurred with the help of whom? His assistant name. What's his name? Hans Zeiser. Okay, or Geiger, we can say Hans Geiger. He is one of the assistants of Rutherford. He only noticed that number of alpha particles scattered by an angle greater than 10 degrees. Okay, so that is what it is. So with that only, with that prediction only, nucleus has been discovered. So this experiment you can draw in our classwork also if you want. So hope you all understood. Anybody is having anything doubt, you can ask me. So why they are using here slit? Anybody can tell me, all of you, why they are using the slit? Because to make all the alpha particles to pass through this small hole, so that they can only strike the gold foil at a particular point. So if I release normally, these alpha particles will go in a different directions, so that the results will never be that much occur. So that is why to make all the alpha particles to pass and hit this gold foil, so they are allowing to pass these alpha particles through the small slit. That is what small hole. So how many for 1 second? That is all we will study in our tomorrow's class. Are you understand everybody? This one, anybody having doubt, please let me know. Clear, Shruti, Umar, Tejaswini? Yeah. Tanishkar, Tanishkar. So this is what gold foil experiment. So if you understand this, then we'll go with from here. We'll continue in the tomorrow's class. Thank you all of you. We'll meet in tomorrow's class.